let's look at one more area problem. So, for example, I want us to find the area of the region R that lies below the parabola y equals 4x minus x squared above the x-axis and above the line y equals negative 3x plus 6. So the first thing we're going to do is take our two equations here and find out where they intersect. So I'm going to set them equal to each other. And solve. Move all the terms over to one side. And factor. I get two intersections. I get x equals 1 and x equals 6. Plug them into either function to get the corresponding point. 1, 3, 6, negative 12. Well, remember we want what's above the x-axis. So in the end, this isn't going to be a point of interest for us. So the first place that they intersect is at the point 1, 3. And then if I look at this line here, when x is 2, y is 0. So when x is 2, this line crosses the x-axis. And remember, I want just the part above the x-axis. So there's my line. Now I'm going to graph this parabola here. If x is 1, or sorry, if x is 2, y is 4. And if I plug in 4 for x, I'll get 0. So here's my parabola. And I want the part, the region that's above the x-axis, above the line, above the x-axis, but below the parabola. So that is the region that I'm looking at. And so let's find the area. Well, if I use vertical strips, you're going to have to see that we're looking at a top and a bottom here. So if I look over there, the top is the parabola and the bottom is the line, but over here on the right, the top is the parabola and the bottom is the x-axis, which means I'm going to need two integrals. If I'm choosing for this area here A, if I want to choose the order dy dx, okay, so let's see, between x equals 1 to 2, so if I'm looking between x equals 1 to 2, that's going to be the first chunk. So from 1 to 2 here. And what is my top function is the parabola. So 4x minus x squared. And the bottom is the line, minus 3x plus 6. But then over here on the right, so x goes between 2 and 4. So 2 to 4. And then my top function is still the parabola, 4x minus x squared, but the bottom is now the x-axis, which is y equals 0. So to compute this area, you're going to have to compute these two integrals. Now, if you wanted to switch the order dx dy, you would only need one integral to compute this. But let's just go ahead and keep doing it this way. So the integral from 1 to 2, if I compute this first integral, you're going to get 4x minus x squared plus 3x minus 6. And then this will be the integral from 2 to 4, 4x minus x squared. And then compute this. It's going to be, so that'll be, if I combine 4x and 3, it'll be 7x. So 7x squared over 2 minus x cubed over 3 minus 6x from 1 to 2 plus 2x squared minus x cubed over 3 from 2 to 4. And if you plug these in, you should be getting 15 halves. So sometimes it's necessary for us to use two iterated integrals like it was here. But again, I think if you change your order of integration, you would only need one iterated integral instead of two.